Alrighty, welcome back. Continuing with the advanced EMT course. Again, like normal, we're using the Pearson's Advanced EMT Clinical Reasoning Approach, second edition, the updated version. Chapter 8, Human Body Systems. Um, I will say, um, if you listen to anything that's coming out of my blowhole, please listen to this. Read these chapters. But if any chapters at all, as you should read, this one is one for sure. There's a lot of chemistry in this chapter that we're just going to touch on in this lecture, but you really need to read the chapter to get it through. Okay. All right. Starting off with this topic. Um, in order for you to know what's abnormal, you have to know what is normal. They're going to talk about different structures of the body. We're going to start talking about anatomy, which is actually the study of the structure of the body. It's broke down to two categories: gross anatomy and microscopic anatomy. Then we're going to talk about physiology, which is the study of the function of the body and all the systems. Different organizations of the body layers. At the very microscopic layer, there's chemicals, then there's cells, which are the building blocks. And then you get a group of cells together doing the same thing. That's tissue. This tissue that will organize together and become an organ. You have several different organs will create a system, and then the total system will create the organism. Again, the cell is the building block. Inside, you have the cytoplasm, which is all the fluid and liquid version. Uh, the organelles are specific structures within the cell. Again, groups of cells form tissue, organs, and systems. They put the word homeostasis here. If you remember from your EMT class, this is the state of balance that the organism will maintain so it'll function properly. Cells are composed of chemicals surrounded in a chemical environment. The term chemistry is the study of composition of substance and interaction between various elements and compounds. Chemistry will allow cells to engage in metabolism and maintain that homeostasis. A substance that can't be broken down any further, that's an element. If you remember back to your high school chemistry class, the periodic table, those are all elements. These are structures that cannot be broke down any further. The smallest unit of an element is an atom. These atoms have subatomic particles, which are electrons, which are negatively charged, protons, which are positively charged, and neurons, which are neutral, right? Um, so some atoms are capable of either gaining or losing electrons, and this is how they connect to other atoms is through opposite charge. So, like a magnet, the positive and negative will attract. It wants you to define the following terms, but I went ahead and done that for you. An ion is a charged atom or group of atoms. A cataton is a positively charged ion, and anion, is a negatively charged atom. An electrolyte is a substance that dissociate into negative or positively charged ions when you put them in water. So some of the electrolytes like sodium, potassium, magnesium, calcium, those are all electrolytes. And that comes into play and important to us when we're talking about dehydration. Here's a typical structure of an atom. You can see the protons and the neurons in the middle being circled by the electrons. In the body is the most comprised elements in the body is hydrogen, oxygen, carbon, and nitrogen. These are the four most predominant elements in the body. Here's a table that shows all the other elements that's in the body. The body is composed largely of water, 60% of your weight. Where this weight is located is intercellular, has 75%. So inside our cell has most of the water. Extracellular, which would be outside, would be 25%. This could be either in the intervascular, inside the vessels, the veins, the arteries, capillaries, or interstitially. That's the space in between, like the capillary bed and the cell membrane. It's also sometimes referred to as the third spacing, and I will probably refer to it as the third spacing from here on out. A solution is form particles in a body fluid. So a solution is a particle in fluid, like electrolytes, carbohydrates, your proteins, your lipids, your drugs. So how does water move across this semi-permeable membrane of a cell? It's called osmosis, and it goes from a lower level to higher solute concentration. And they will move to equal out, or the homeostasis, right? So water is going to move to equal itself out throughout the solution. This moving or will cause osmotic pressure, and this is what is able to pull the water into the cells. It's measured in milliosmoles. Part of this osmotic pressure is called ontonic pressure, and this is how the water is actually pulled back into the intervascular or back into the bloodstream. Like I said, if you read your chapters, it'll get into more detailed, a lot of detailed how this works, but we're just going to hit on it in this lecture and move on. They want you to define these other terms. Again, I've done the work for you. Isotonic, and this is important to us when we're talking about fluid replacement in a patient, right? So isotonic is two solutions that have the same concentration. So they're going to have the same osmotic pressure. Hypertonic is a solution with higher concentration, and hypo is a lower relative concentration. Osmolarity of the body fluids is between 280 and 310 OM/SL. This is talking about the different solutions and what happens. These are all in your book. Sodium potassium pump. This is important. This is how water moves, and that's what this is for. The sodium potassium pump is proteins on cell membranes that keep ions of proper level inside and outside the cell. So inside the cell, the cation is usually potassium, and outside the cell is going to be sodium. Now, this does require energy. So if the cells are not able to make energy for some reason, like if it goes into anabolic metabolism due to like lack of oxygen or whatever, this sodium potassium pump is going to not work as well. And if enough water always follows the sodium, so if we don't get enough sodium expelled, the water is just going to stay inside the cell and it'll burst and die eventually. Here's kind of a nice picture, kind of explaining how this works. Energy, right? We need energy for the body to work. All cells need energy. It's a chemical process of breaking down glucose. It requires a constant supply of glucose and oxygen. It gets the glucose from the digestive tract. We eat, digestive tract, digest. That's where we get the glucose. And of course, the oxygen comes from the respiratory. Metabolism and anabolism is to synthesize more complex substances, and this requires energy. And catabolism, this is what the actual process of creating the adenosine triphosphate, or ATP, which is what the cells use for energy. Adenosine triphosphate, or ATP. And this is how that works. The first phase of it, this glycolysis, it gets glucose, broken down into pyruvic acid, pyruvic acid, and this is an anaerobic metabolism, so it creates very low energy, just this first phase. The second phase going to aerobic. This is where we introduce the oxygen. Complex process that results in a large amount of ATP releasing the heat, right? And if for some reason the oxygen level or something happens to the interrupts the oxygen, if it's not restored quickly, the cells will die and death to the individual will occur. And this puritic acid will turn into lactic acid because the oxygen can't bind to the hydrogen and the carbon. So it becomes a lactic acid and it builds up and you get acidotic and die. A pH is a potential of hydrogen. Acid is a substance that donates a hydrogen. And alkalis can accept that hydrogen. Acid-base balance is measured on a pH scale. It's 0 to 14 with normal about 7.3 to 7.4. An acid, if something's acidic, it's higher. It's got a higher concentration of hydrogen ions. And the alkalytic is reversed. It's low. There are buffer systems to keep this from happening, right? We have excess hydrogen to convert substance to prevent acid accumulation, maintaining an acid base. The two systems that really work on this are your renal system, your kidneys, and your digestive system. I'm sorry, your respiratory, right? The kidneys will release bicarb to fight the acid or to lower the hydrogen. And of course, you'll breathe faster to get rid of the carbon and the acid. Membrane potential is a chemical phenom reflected by the difference in concentration of electrolyte charged ions on the inside and outside. Electrical charge of the ion determines the ability to gain or lose electrons. Electrical current is a movement of ions that have too few or too many electrons. And ions will move from an area of greater abundance to an area of less abundance, like through osmosis or diffusion. The membrane potential, the sodium potassium pump, maintains a negative charge within the cell and restores differences in charges when it repolarizes. And that's what they start talking about polarized and depolarization. We'll see that, especially when we're talking about cardiology. Cell membrane, it's got a semi-permeable. This will allow water and small molecules to go back and forth and move through it. Consists of a double layer of molecules called phospholipids. Phospholipids. Inside the cell, you got channels. This is how the substance moves through the cell at certain times. Movement of other substance regulated by electrical charges of the molecule. Cytoplasm, that's the fluid. We talked about it. And the nucleus contains the DNA, so like the brain center. DNA is ribonucleic acid or RNA. It's like the building blocks. Transcribed by ribosomes into proteins. So it takes this RNA or the ribonucleic acid and turns it into proteins through the ribosome. The Golgi apparatus, it modifies protein prior to secretion. The mitochondria, that's where the ATP is produced. Vacuoles, they store and transport proteins. Centrales provide support and form microtubes and spindles. Lysosomes destroy waste. All right, let's talk about tissues. Tissues are a group of specialized cells, and they're surrounded by a matrix, like we talked earlier. There are 4 types of tissues in the human body: epithelial, connective, muscle, and nervous tissues. Now we're going to skip into the anatomy, the anatomical position. As you remember from your EMT class, it's standing, facing forward, feet together, arms to your side with your palms out, right? Then they talk about the three planes. So you got the frontal plane, which is the mid sagittal. I'm sorry, mid sagittal, uh, which is divides the body left and right. Sorry, the frontal, front and back, and the transverse or the horizontal, it top and bottom. These are the three planes. And here's a nice picture of it. They give some directions here, like superior to the head, inferior to the feet, stuff like that. Lines of reference, mid-axillary. It's that imaginary line that goes underneath your armpit and splits your body in front and back. Mid-clavicle, it's just as it states, it's halfway across the clavicle bone. And um, and your abdomen is divided into either 4 or 9 regions. It's actually 9 regions, but for medical purposes, we do 4. Anatomically, it's 9, and for medical, it's 4. Right, left upper, left lower, left right, or right upper, right lower quadrants. Body has different cavities. The dorsal cavity is where your cranial and your spinal. Your ventral cavity consists of the thoracic and the abdominal pelvic cavities. Here's a nice picture of that. An organ is tissues, composed of tissues that work together. Most organs can consist of different varieties of tissues. Organs and tissues interact to carry out complex set of functions. So an organ has a job or a function to do. Start talking about the different systems. The skeletal system consists of bones, cartilage, tendons, and ligaments. What's it do? It provides structure, support, and protection. It's a reservoir of calcium and bone marrow, where the blood cells are created. Uh, Skeletal muscle will actually let us move. 206 bones, and they're classified as long, short, or flat. So, what is cartilage? Cartilage is a protective covering over the bone ends and joints where they come together, right? Tendons. What are a tendon? It connects what? Muscle to bone. And a ligament will connect bone to bone. Short bones, they're roughly cube shaped. They'd be in our wrist and ankles. Flat bones would include the sternum, the ribs, scapula, the pelvis. Long bones are extremities, and they consist of different things. Here's a nice picture of both your axial and appendicular skeletal system. Remember, the axial is your skull, your thoracic cavity, your spinal column, and your appendicular is pretty much your extremities and how they attach to the body, like your shoulder and pelvic girdles. Straight line, right? Skull, spine, ribs, sternum. This is your axial skeleton. And the appendicular skeleton is your extremities, both upper and lower, and the bones, shoulder, and pelvis. The muscular system, muscle tissue is built from unique proteins, actin and myosin. They're arranged in filaments and can contract and relax. This is how we move. These contractions are a nervous stimulation, which requires complex chemical interactions, right? Types of muscles. We have 3 types: skeletal or striated, attached bones and allow for movement. This is also called voluntary. We can move these muscles. We can do that on our own. Smooth muscles or involuntary control. It's usually in the organs like digestive tract. It's also inside your intravascular, like your arteries and your veins. This is how they can contract and change diameter. And cardiac muscle is an involuntary control. Um, it has a unique function to allow the heart to pump blood throughout the body. We're going to talk about the integumentary system, which is skin, largest organ of the body. It maintains warmth, protects from external pathogens. It has the oil and sweat glands, which will help maintain both temperature and fluid balance. 3 layers. You got the epidermis, dermis, and subcutaneous. And I'm sorry if I'm going fast, but this is all kind of review from your EMT. There's a nice picture of your skin. This is a picture that you've seen all the way from grade school on through. Respiratory, its main function is that gas exchange to bring in oxygen and to eliminate carbon dioxide. Now, if you've ever been to any of my classes, you'll be sick to death of these two terms, but I always make sure you know the difference between respirations and ventilations. Respirations is the actual exchange of oxygen, carbon dioxide down at the alveoli level. And ventilation is that mechanical effort or process of breathing, right? Moving air in and out of your lungs. We're talking about partial gases. The amount of pressure an individual gas contributes to total pressure. It's usually whatever the gas, it's PA, like partial pressure of oxygen is PaO2. Our air we breathe is 79% nitrogen, 21% oxygen, and 1% of other trace gases. They go from a higher to lower concentration. This is called diffusion. Carbon dioxide is carried in 3 ways. It can form a bicarbonate when it's connected to hydrogen. It can bind to hemoglobins or it can dissolve in the plasma. And most carbon dioxide is carried back to the lungs through the plasma. Oxygen used in cells is used in cells, so it's the blood that returns from the heart is usually deoxygenated. It'll still have small amounts in it, but not enough. Very low. The partial pressure is about 40 millimeters of mercury. Oxygen will diffuse from the villi back to the capillaries. This will be oxygenated blood. The amount of oxygen blood will increase, of course, and the partial pressure will go up to 100 millimeters of mercury. Boyle's law. Boyle's law comes into effect if you've ever done a diving class. And also, if you've ever flown or if you plan on becoming like a flight paramedic or flight nurse, this means the pressure in a fixed container, if you have the same amount, is going to change. The pressure in a fixed gas varies with the size. So what that means is, if you have, let's just say, 100 whatever psi of oxygen in a D size tank or an M size tank, and we force the same thing down to D size, we're going to get more psi, right? Inhalation is an active process of breathing in, air diffused in, and exhalation. The thoracic cavity is going to decrease in size, the diaphragm is going to relax, and it's going to let air out. This is this is breathing in and out. Your upper airway warms, humidifies air, filters out particles through your nose, mouth, oral pharynx, and nasal pharynx. Lower airway would include the larynx, trachea, left and right main stem of the bronchi, bronchioles, um, the alveolar ducts, and the alveoli at the very end. Lungs, you got a respiratory membrane. This is a gas exchange that occurs between the respiratory and cardiovascular system. Lungs divided into sections called lobes. You have 5. You have 3 on the right, 2 on the left. You have 2 on the left because of the heart, the way it sits. Lungs are covered by a vesicular pleura, which is a layer, protective layer. And then you have a pleural lining against the rib cage. And in between those 2 layers, you have some fluid called pleural fluid to help lubricate when those lungs expand or moving. If not, they start rubbing, cause irritation and pain. There's a term for that called pleurisy. We'll talk about that later. We're talking about circulatory system of the respiratory system, how the lungs get their blood. It enters through the helium, and this is the point of entry of the lungs for the bronchus, the bronchial artery and veins, pulmonary artery and veins. The pulmonary vessels carry blood back and forth to the heart and the alveoli, and the bronchial vessels carry oxygenated blood from the aorta to the lungs. And it returns it through the vena cava, the two vessels. So the bronchial artery will carry blood directly off the aorta or the aortic arch to the lungs, so they get their blood supply, the cells, and the bronchial vein will bring it back through the vena cava. Two phases of ventilation. That would be inhalation, exhalation. Respiratory cycle occurs 3 to 5 seconds, which gives us a 12 to 20 breaths per minute. What is our primary stimulus to breathe? What makes us want to take a breath is our hypercarbic drive, which is your brain. The medulla oblongata is sensing how much carbon is in your bloodstream. And if your carbon goes up, you'll breathe more. And if for some reason this system is not working, we'll go into that hypoxic drive where it measures the oxygen level. And this comes into play a lot when we're talking about COPD, which we'll talk about later. They run on a hypoxic drive, not the hypercarbic drive. Tidal volume is how much we breathe in air in one breath, typically about 500 ml. Minute volume is we take the tidal volume times our respiratory rate. This gives us our total minute volume. Vital capacity. This is the volume of air exchange in a single maximal inspiration expiration. And residual volume, so we don't breathe out all our air in our lungs, because if we do, our alveoli will collapse. So we have some natural PEEP in our lungs. This is called residual volume. This is the amount that remains after we breathe out. We start talking about the cardiovascular system, which consists of heart, blood, and the vessels. It's a closed, pressurized system. The oxygen pumped from the left side of the heart through arteries to the capillary beds where the exchange happens. The deoxygenated blood travels back to the heart through the venous system, or it goes to the right side, which then pumps it back to the lungs to get reoxygenated. Blood is tissue. Um, there's plasma and formed elements. We have about 5 liters in the human body, adult. Plasma is the liquid that is the transporting agent, right? Which consists of proteins, nutrients, elements, gases, waste. We also have red blood cells, which are the hemoglobin, which the oxygen is attached to. It carries the oxygen to the cells. A mature red blood cell has no nucleus, so the hemoglobin can fill that space, and its lifespan is about 120 days. Hemocrit, hemocrit, hemocrit. Sorry, your hemocrit is a percentage by volume of formed elements in the blood. When the majority of that is red blood cells. This is how they take a hemocrit at the hospital. It's a blood test. It'll tell you your red blood count, your red blood cell count. Types of blood, we have 4. We have type A, type B, AB, or O. A has the A antigen. B, of course, has the B antigen. AB has both of them, and O has neither one. Then we have RH factors. This is your positive, negative. So you can be A positive, A negative, B positive, and so on. This is important when we're talking about matching blood, because your body won't accept other blood types except for O. If you are A, if you're A positive, you can only get A positive. If you're B negative, you can get B negative. If you're AB positive, you can get A positive, B negative, or O. O can give it to everybody else, but can only take O. Talking about white blood cells, I call them the soldiers or the troopers, right? They're there to protect against the invading antigens, and they also help in injury by helping develop the inflammation. Platelets, I call it the JB Well, right? They Their active chemical events respond to an injury. They create the blood clot, right? They start that clotting cascade. The heart is a muscular pump, circulates blood. It's roughly the size of your fist. It's located in the mediastinum between the lungs, surrounded by a pericardium, which is a protective sac. Four chambers, or functions as a two-sided pump simultaneously, right? It's a two-sided pump that works at the same time. Right side pumping it to the lungs, left side pumping it out to the body. Nice picture of your heart, including your valves, your tricuspid and your bicuspid. The right atrium gets deoxygenated blood from your vena cavas and pumps it down into the right ventricle. And from here, the deoxygenated blood is pumped out um, um, through your pulmonary artery. Goes to the lungs, get oxygenated, comes back to the pulmonary vein, into the left atrium, which pumps to the left ventricle, and the left ventricle out to the body, up through the aorta. Conduction system. The SA node is our pacemaker, and then from the SA node, it goes through the atria and down into the AV node, where it is delayed just a little bit so that the ventricles can fill. And then it goes into the bundle of His, or the bundles, which is the bundle of His. You got right and left. And then finally it goes down into the Purkinje fibers and will send a signal for the ventricles to contract. I just talked about this. Specialized properties of myocardium, which is the heart muscle, allows it to contract in uniform rhythmic fashion to pump blood. Heart flows regular cycle of events with each beat. The electrical event will cause a mechanical contraction. And this electrical activity is an exchange of sodium, potassium, and other ions, calcium specifically. Calcium required for contraction of the myocardium cell. We have two phases. We have the systolic, which is when it contracts, and the diastolic when it relaxes. And our heart function is two hearts in one, right? One pumping it to the lungs to get oxygenated, and the other to pump it out to the body. The autonomicity, this is the heart self-depolarization to initiate its own electrical activity. Excitability allows the myocardial cells to respond to this impulse, and then it contracts. And conductivity allows the electrical impulse to move across from one cell to another. So we have that systematic, rhythmic contraction. Talking about cardiac output, this is how much blood is ejected from the heart in each beat, or 1 minute, I'm sorry. And this is determined by two factors of stroke volume, which is how much each beat, which is about an average of 70 ml every time your heart contracts. And the second factor is your heart rate. And any type of variance in either one of these can affect your cardiac output. And our average cardiac output is 4.9 liters per minute. We talked about this preload, contractibility of the heart, and afterload. What is afterload? This is the what resistance that your heart has to pump against of the vessels. And preload is the amount of blood coming back to the heart. Vascular refers to blood vessels. We have three different ones. We got arteries, capillaries, veins. Nice picture of it. The arteries and veins are three layered, where the capillaries just have one layer. Hemodynamics. It's the goal of the cardiovascular system is to perfuse. So hemodynamics we measure through our blood pressure. Arterial blood pressure is the force the blood exerts on the artery walls. We measure two numbers. The systolic pressure is during the ventricular contraction or systolic phase, and the diastolic pressure is when the heart's at rest. And this is the pressure exerted against the walls when at the lower pressure. This is how we get our blood pressure numbers: systolic over diastolic. Normal is 120 over 80. We can measure the mean arterial pressure, and then we can measure pulse pressures. What could affect your blood pressure? Function of your heart. Is it working right? The amount of blood and the capacity of the vascular system, right? So this could all affect your blood pressure. So if our vessels, our brain determines our pressure is dropping, it's going to constrict our blood pressure vessels, which is going to uh, raise our blood pressure. The volume of blood and function of the heart is determined by the cardiac output. Moving on to the nervous system. This allows integration of sensory input and coordination of response. Along with the endocrine system, the nervous system allows for control and communication. Here's a picture of nerve endings. Neuron structures and function are basic units of structure and function of the nervous system. Neurotransmitters allow communication between neurons and target tissue. And these are different types of neurotransmitters: acetylcholine, norepi, dopamine, serotonin, and GABA. Central nervous system, this is our spine, our brain, and our spinal column. And the peripheral is neurons outside to this. We have a somatic or a voluntary function. This is how we move. This is stuff we can control. Involuntary or atomic, that we'll talk about and split into the sympathetic and the parasympathetic. The fight or flight or the relax and digest. Neurons are classified by their function. Are they sensory? Are they motor? Are they interneuron? Here's your brain and different parts of it and what's responsible for that. Brain is the central organ of the nervous system. The brain is inside the cranium, cushioned by cerebral spinal fluid, surrounded by meninges, which has three layers: the paramotor, the arachnoid, or the dura mater. Cerebrum is part of the forebrain. This is our center for conscious and higher thought. The thalamus is a coordinate center for signals that travel between the cerebellum of the cerebrum, and the spinal cord. The hypothalamus coordinates hormones of the endocrine system. The brainstem is in charge of the core body functions like your heart rate, respiratory rate, and body temperature. We have cranial nerves. There's 12 pairs, and each one serves a different function. The RAS, or the reticular activating system. The network of neurons in the brain, thalamus, and cerebrum, responsible for consciousness, sleep wake cycle, and your attention. When we talk about going back to this, we're talking about an altered mental status. This is what we're talking about. It's a variation in this RAS. For some reason, trauma, drugs, whatever, illness can affect that consciousness or your attention. Spinal cord, it's a large bundle of nerves that goes from the brainstem all the way down to the L2 or the lumbar vertebrae. Neural tissue is arranged in bundles called tracts. And whenever the spinal cord is completely severed, all communication below that point will cease. Peripheral nervous system begins with the spinal and cranial nerves enter and exit. The meninge covers the spinal cord. Different types of neurons or nerves, the sensory nerves. These are affect and they travel towards the spinal cord. Motor nerves are effect and they travel away. Voluntary system or voluntary nervous system or somatic. Any nerves involved in action that the brain must constantly think about, right? Like movement. Anatomical nervous system, the sympathetic or the fight or flight, or the parasympathetic, which is the rest and digest. We'll talk more about that later. Moving on to the endocrine system. The endocrine system is basically for regulatory purposes and to maintain that homeostasis. It's ductless glands that secrete chemicals or hormones into the bloodstream in order to maintain that balance, right? Different glands and where they're at. The pituitary gland is the master gland, secretes tropic hormones. The hypothalamus controls and influences the pituitary gland, so it's the pituitary gland's boss. The pancreas has dual function with both endocrine and exocrine roles. We'll talk about that here in a little bit. Its biggest function is production of insulin. The adrenal glands, they sit on top of the kidneys, and this is what stores and releases epi and norepi. The GI system, or the gastrointestinal, uh, receives and digests food, absorbs the nutrients, and excretes waste. The GI tract would include the mouth, pharynx, esophagus, stomach, small and large intestine, the rectum, and the anus. Here's a nice picture of that. The esophagus is a muscular tube that goes from the oropharynx onto to the stomach. The stomach is a muscular container found in the upper left quadrant, and its job is to break down the food we eat by creating acid. Small intestines divided into three sections with the duodenum, the duodenum, and the ileum. And its job is to absorb nutrients from our food. And the large intestine's job is to absorb water in the form of the stool. Accessory organs would include the saliva glands, the liver, the gallbladder, and pancreas. Let's talk about this for a minute. The saliva gland starts the process of digestion as we're chewing, lubricates as we're chewing. The liver creates the bile. It's also where glucagon, I'm sorry, your stores of sugars are stored. The gallbladder, which um, is a storage vessel for the bile, which is created by the liver to break down fats. And our pancreas. Why would the pancreas be involved in the digestive system? Because it secretes bicarbonate into the small intestine to neutralize the acid from the stomach. The peritoneum is a thin epithelial lining surrounding most of the abdominal organs. We have two layers. We have a visceral layer, which goes over the top of the organ, and then the parietal layer, which covers the entire abdomen. Urinary system. We have the kidneys and urinary tract. Nice picture of it. Kidneys maintain fluid electric balance. They help to maintain the blood pressure and filter waste. The kidneys are very important, especially for the water balance or the maintain fluid and water balance. Urine drains from the kidneys into the ureters, which carries urine to the bladder. Nephrons filter blood, manage electrolytes, and expel waste as urine. These are in the kidneys. Nice picture of a cross picture of a kidney. Ureter is inserted in the bladder. It's a hollow muscular organ found in the lower pelvis. Upon urination, bladder contracts. Urine passes through the urethra on out to the penis in the males or the vagina in the females. Kidneys affect the pH through secretion of bicarbonate. So if we have a lower pH or an acidic pH, the kidney will release bicarbonate to bind with it to neutralize it. Reproductive system consists of organs that store the DNA, right, for male and female sex cells. Sperm and eggs, they both each carry 23 sets of chromosomes, combined upon fertilization for a full set of 46. So the male gives half, female gives half. The male reproductive organs are the testes, the prostate gland, the penis. Nice picture of it. Females are the ovaries, fallopian tubes, the uterus, the vagina, and the vulva. Each month, a female of the childbearing ages will create an ovum or an egg, and it's ejected from the ovaries into fallopian tubes. If fertilization does not occur, the epithelial tissue in the uterus will slough off, and this is what creates the menstrual flow. Nice picture of the female reproductive organs. All right, chapter summary. The human body consists of complex structures and functions. Systems work together, allowing the body to maintain homeostasis. We must be able to distinguish between abnormal structure and function from normal. First step is to recognize patients. This is the first step in recognizing sick or injured. Understanding the roles of these different systems, like the respiratory, nervous, cardiovascular, endocrine, is critical. I know we went fast. Like I said, this is a review, but please read this chapter. There's a lot to this chapter, a lot of chemistry in there. So please read it. If you never listen to a word I say, please do that. All right. Until next time, we will see you on chapter 9.